All entering, no, once I start class, no need to wish, directly you are supposed to enter. Already late and no need to wish a teacher and disturb the class. Now, first case we are discussing when applied force is 10 Newton. There are two persons are there. Let's see what about the work done by them. Now, I need not to put so many things. I'll just write N1, this N1, 3G, N2, yeah, let's carry on now. Okay, this F equal to 10 Newton like this. Then, what direction the friction will act? As the friction on the upper block should be like this, and the lower block, it has to be like this here. And then, what about the friction, static or kinetic? We know some formula. Okay, let's assume that they'll move together. We don't know any formula, just we'll work out typical our method here. F minus F equal to 3A, F equal to 2A. F equal to 5A, then F equal to 10. Acceleration is how much? 2 meter per second square. Okay, this is the acceleration. Now let's calculate the frictional force. F is equal to 2 into A. Okay, this is 2 into 2, 4 Newton. And what is the limiting friction? We know that limiting friction should be equal to mu n or mu m1g. Then mu is 0.52 into 10. 10 Newton is the limiting force. How much of frictional force acting? 4 Newton. So definitely less than FL. No slipping between blocks. Now, sir, like I don't know this concept. Okay, go back and learn from there. Already explained, no? So you should be able to recollect all the things. Okay, now there are two, what is the acceleration? Both will have common acceleration. No slipping occurs. No slipping between blocks. Both will have common acceleration. In 2 seconds, what is the displacement of block 2 kg and 3 kg? Okay, displacement of block 2 kg. I'll call this is 1. We'll use symbol 192 like this. Displacement of block 1. A t square by 2. I think both will have same displacement. Acceleration 2, time is 2 square by 2. 4 meter. So in 2 seconds, both will have displacement of 4 meter. Both will undergo displacement of 4 meter. Okay, let's do one thing. Person A. What about work done by friction on the block 2 kg by the friction? Work done by friction with respect to person A. With respect to person A, we'll discuss the problem. Work done by friction. I'll do one thing. A and B on 2 kg block. We'll write symbol like this. It should be equal to how much? F into what is the displacement of block? That will be x2. Frictional force is how much? 4 into 4. 16 joules. It does positive work. Okay, that one. Similarly, work done by friction on the 3 kg block. Displacement of 3 kg block is x1 we are taking. So this will be minus of 4 into 4, 16 joules. Net work done by friction according to person A will be 0. How much of friction force does work on the 2 kg block? The same work, negative work it does on the block 3 kg. Net work done in fact is 0. Okay, agreed. This with respect to A, that one. Now with respect to B, we'll see what conditions will arise. Person B, what will be comment? Person B, there's a frictional force 10 Newton acting. and person B, no. So here I'll bring a pseudo force. And the person B where is there? It's standing on this one, no. And you will say that pseudo force will act here, 2A. Friction on this one also. Now what will be comment from person B? Block is at rest. We just say that as block is at rest. Two kg block is at rest. So therefore, what is the work done by friction? Will be 0, no, on the 2 kg block, because the person says that what is it, that it is at rest. Who will balance friction force? The pseudo force. So like this, what is the conclusion now? Work done by friction is 0. For the person A, work done by friction on the block 2 kg, it is 16 joules. For the person B, where is the person B? On the accelerating frame, no? Because the 3 kg block is accelerating. And what is the acceleration? Already we have calculated. So now who is the person B? Person B is like some sort of non-inertial frame. And what about person A? Will become like inertial frame. So what is the work done by friction? So he is going to write very clearly, work done by friction is equal to 0. The reason for that, block is at rest. So look at the now frame of reference. Person A and person B, are they the same frame? No. Person B is a non-inertial, person A is the inertial frame. So what is a person A? Person A will become inertial frame. What about B? Will become non-inertial frame. So what is work done in different frame of reference? Will be different, is telling. The frame of reference, will it depends on the so like the work done depends on frame of reference. The answer is yes. So what is the conclusion now? Work done by the friction on the block 2 kg in the ground frame is 16 joules. In the 3 kg block frame of reference will be how much it is? It is 0. So therefore work done is different in different frame of reference. So what is the some thing will write it? Work done by friction on 2 kg block I'll write comment here. Work done by friction on 2 kg block is 16 joules in with respect to ground. Who is a ground? Who is a ground? Person A. Person A or inertial frame. And is 0. Okay, we will write sentence. It will be. This is the very most important thing. What I am concluding is very, very, very important. I am just explaining through problem. That's all here. Work done by friction on 2 kg block is 0 with respect to block 3 kg, or there is a person B, or who is he? Is a non-inertial frame. So what is the conclusion now? Work done, therefore what is the conclusion we can make it? Work done is different in different frame of reference. Therefore, one conclusion. Work done will be different in different frame of reference. I wanted to put this statement. If you look at the especially books like SE Verma, why you find very difficult objective questions in SE Verma? This is a thing. one options will be there. What students will just read and remember. In physics, conceptual questions are very dangerous because numerical, okay, we can do it. Conceptual questions is not something you have to read and just remember. For each and every sentence, for each and every option, we should imagine a system like this. Okay, this is what happens in the advanced or the exams where you'll get a conceptual question. Students will think, okay, fine, like chemistry, just read and some assumption, okay, you can conclude, but not like that. In physics, every sentence will be some numerical. Now, work done be different in different frame of reference. This sentence is there. To understand this, we need this problem, otherwise not possible. So even if you're reading a textbook, each and every sentence what happen need some diagram. You have to assume a diagram, imagine a diagram, you have to analyze the diagram, then what will happen? The sentences what you're reading is meaningful. Just mere reading will not help you. How many of you really read this one? Some of you have taken foundation courses in 8th, 9th, 10th. How many of you really read physics of this kind? Not possible, no? Because we are more bothered about what? How soon I'll finish off this chapter. Definitely I'm telling you this one, physics, actually when you're reading a paragraph, definitely you have to at least one diagram is needed. Whenever you read any paragraph. Like that, you just imagine the textbook 4-5 pages you read means minimum some 30 diagrams you are supposed to draw here. Then only what happens, you have understood that. So that will be very difficult actually, students. So what I suggest is like read that one, somehow you gather the theoretical information, start numerical, then in numerical at least make observation of this kind. Okay, the learning physics is little bit very complex. If you just read like in chemistry books, not possible. You take SE Verma. He has not given diagram, but he is explaining the system. Means he's asking us to imagine like this. Okay, then carry on the physics. It's a very beautiful book, but sorry to say that now we are entered into competition where we feel like, okay, all very silly problems are there, everything. Intentionally has not given diagram for the questions because he wanted students to imagine the diagram. See the beauty of book. He wanted to help you. Okay, now I'll make observation. I'm showing the complete. Suita, what is there, explain to me? I have given all the equations, everything. What is there me to explain? Tell me, like the block is not moving. Force into displacement. If displacement 0, work done 0. It's over, no? What else you want me to explain? Please, you have to put effort, no? Everything if I tell, then what actually you are doing here? Okay, this is a pseudo force. 2A is a pseudo force. Okay, now 30 Newton. Carry on. Those are completed. Go for 30 Newton. We'll take the situation F equal to 30 Newton. We'll see what conditions will arise. Okay, this negative sign. Yeah, fine. The same data will I'll bring another page. Now this will be F equal to 30 Newton. We are discussing case 2. What actually happens here? We are not sure slipping occurs or not. So let's carry on. Let's not use formula, because we know method whether slipping occurs or not. We'll use that particular method. So this will be F minus F equal to 3A, F equal to 2A. Okay, adding up this, F equal to 2 plus 3 into A. So what is applied force? Applied force is 30. Acceleration 6 meters per second square. Then F equal to 2A, 2 into 6, 12 Newton, greater than FL. No. F equal to 12 Newton. So what is this friction? So slipping occurs. Slipping occurs between blocks. So we assume no slipping, but in fact slipping occurs. So I have to change the diagram. We have to just change the diagram here. Now here the friction will be FL, this will be FL. They will have different accelerations. So here we took it this to be 2, this is to be 1. So A2 and A1, I'll write it. Then let's write the accelerations. A1 is equal to F minus FL by 3.
20 by root 3.
Root 3, why root 3?
No, only 3, so only.
6.6.
6.6. This is acceleration. Similarly, A2 should be equal to
5
Five.
meter.
F2 by 2. FL, no, sorry. FL is 10 by 2, 5 meter per second square. In time interval 2 seconds, the displacement of blocks will calculate. X1 will be A1 T square by 2. So 20 by 3 by 2, 2 square. Four, 40 by 3 meter. Displacement of other block. X2 is equal to A2 T square by 2. 5, 2 square by 2. So this will be 10 meter. See, you can see from clearly in an interval of time 2 seconds they're having different displacements. Let's calculate the work done by friction on 2 kg block. That should be equal to FL into X1. FL is 10 and it does positive work, 400 by 3 joules. So this is what with respect to person A.
By 10 meter you should multiply.
No, work done by friction on 2 kg block, no? 2 kg block is 10. Okay, I didn't see, yeah. Now with respect to A, we'll calculate. Who is the person? Person A is on the ground. Friction does positive work. Okay, similarly, what about the friction on the 3 kg? Minus of limiting friction 10. X2 is X1, sorry, X1. This will be 40 by 3. Okay, same thing. Again, they're different, no? You can check it. What about with respect to person B now? With respect to person B, work done by friction on 2 kg block. We need the displacement of block with respect to Planck here. So FL, the displacement of block with respect to Planck. So x2 minus x1. FL is how much? 10. What is x2 minus x1? So 10 minus 40 by 3. Look at again the work done by the friction, whether slipping is there or no slipping occurs. Altogether work done is different in different frame of reference. That's what he mean to say here. Now look at this one. Work done by friction on the 2 kg block with respect to person on the ground. 100 joules. With respect to person on the block, minus 100 by 3 joules. So work done by friction will be different in different frame of reference. That's the only thing is what I wanted to tell you. I'm not bothered about work done by friction on 3 kg block, just calculating. These two you compare. Very important. So who is a person B now? Is a non-inertial frame. And what about person A? Inertial frame. So therefore work done will be different in different frame of reference, whether slipping is there or not. Make observation. So now you need not to bother now. So whenever they ask you work done, so what is the question we have to ask ourselves? From where you are making observation, I think. Are you getting that one? In which frame? Because the work done depends on frame of reference. So like is it on the block? Is it on the ground? Like that, I think we have to be alert. That's what this question is telling us. It's a very basic and fundamental one. It's not like a numerical. Make observation, I'll scroll down.
Sir, we have to not calculate for the 3 kg block, sir.
Hey, some many head is there for you. I just wanted to tell you, if you are interested, you calculate what is there, that one.
Okay, sir. Okay, sir. Okay.
In non-inertial frame, net work done by friction is 0, sir.
Huh?
In non-inertial frame, we are getting net work done by friction 0, sir.
What do you mean by non? Oh, person B, huh?
Yes, sir. Yes.
For person B, what is a 3 kg block? Rest or in motion?
Rest.
Rest. Then where is the question of friction doing on the 3 kg block for person B? How will it become 0? Okay, huh?
Okay, sir.
Relative motion, please apply. Nothing is there for me. Only in some small thing I introduced. What is that? Work done equal to force into displacement. Work done equal to change in kinetic. That's all over. We are not learning anything new. Kinematics, laws of motion, friction. All three topics you know that you are going to apply. Work done by friction on the 3 kg block with respect to person B will be 0. Okay, if you want, I'll write a chart. But I want students to make observation. Please, I don't want you to everything. If I write it, what is that term? So you do one thing: work done by friction on 2 kg, 3 kg block with respect to A. B also what happened? We'll see friction acting. But for B, what happened? 3 kg block at rest, no, because he's moving along with the block. So when object is not moving, no displacement. So no question of work done by friction on 3 kg block with respect to B. The blocks are given. Initial velocity as shown at t equals 0. Find the net work done by friction.